Hey, g'day guys. Look, Andrew White here, back again. Look, a lot of the times we do very simple houses that have, just square boxes, so we can teach you a lot in a short amount of time. But I understand that we do complex houses, and some of us do some really, really complex houses. And I guess this is a good example of a more upper class house. It's a friend of mine who lives over in Texas. So let's have a look at what we would do to estimate something like this. So you can see that I've gone and already put in, well, my framing was done automatically when I did the walls, and I changed the walls into gables in certain circumstances. I'm going to use control hide here so you can I can break this model down a little bit, and we can see that there are items inside of that roof that would go to hold it up structurally that are really important that they actually get estimated. So how do I go about getting them in? The rafters themselves are reasonably simple. We can choose any face, and I'll give you a quick demonstration here. Let's go back to all, and I'll just create a rectangular box here, and I'll put a roof on it, and choose my ratio, pitch, type of material, and so on, and go submit. Okay, and to create the rafters, it'll automatically do its best, or Plusspec will automatically do its best to associate this with rafters. So I go and choose the spacings of my rafters, the height of my fascia, my evens to feet overhangs, and whether I want a bird's mouth and so on. And if I go in and go submit, it'll do it reasonably quickly. It's a simple roof, so sometimes you might get a black screen, and if I went and did that last, see I've got one there. What it's doing is going through the model and it's starting to do it. It might take 15-20 seconds, and the large roof over there took 3 minutes to do, but it's automated and a lot of things come out very, very quickly. Okay, so if I go and have a look at my structure, I'll just get inside that component there and just go to structure. You'll notice that it went and put in my rafters. Now this is a lucky example. In certain cases, if this had been right on the center, it might have missed a couple of rafters, and I can add them in by using the rafter tool, which is inside of here, and I might have needed one rafter up the center. If I go to my alternatives down here, I have rafters from points. So if I said, well, you know what, I want a rafter here and to here, I can add those in very, very quickly, which is this one here. Right. Okay, so that's how we create rafters, and it's a reasonably automated process. It will take a little bit of time for the computer to do it, and the larger the model, the longer it'll take, but it saves you a whole heap of time. And we can do that on complex roofs. So I'm just going to go and undo that, and we don't need that anymore. And I'm going to go back and have a look at our entire model here. So there's a lot more to roofs than just putting rafters in. Plusspec will do a lot of the work for you, but we still need to have a look at certain areas where we might be missing rafters. And this particular roof down here, I actually added a couple of extra rafters to suit. And in certain cases, we may need to move the rafter outside of the brickwork. So if I went back to all here, and we had a look in here, the brickwork, they put the rafter inside of the brickwork, and I actually just moved it over. Okay, therefore it's doing what it needs to do. It's holding up the batten or the OSB, whatever's required to do that. Now inside of the roof, you'll know we have these things called under purlins. If you're not sure what they do, let's go and have a look. Essentially an under purlin, so these timbers have a span that they can go to, and you can quickly go to Google and find out what the span of a particular rafter is according to the weight and maybe the location that it's going to be placed. And in this case, these rafters, they will only span a certain distance. So therefore, this under purlin has been put in to hold the weight of that. And then we would then use something called a strut or a scissor strut that would distribute that load down to a load-bearing wall. And the best thing about doing this inside of Plusspec is you're getting a good idea of what's actually going to happen and how we're going to have to distribute load. And I'm going to do a couple of these for you. It could be reasonably complex if you tried to do this just by yourself, and there's a couple of methods that you can use. So I use hide rest of model in some circumstances. So I went up to my windows and I set a shortcut preference. So if I wrote in here hide, you can see that I've assigned hide to H, And if I went hide rest of model, I assigned Shift H, and I'll show you what that does. So if I go up here and I went Shift H, I'll just do it again. Oops. Shift H, and I go plus. It'll ask you to reassign it to whatever it is, and you can make that shortcut whatever you like. What that allows me to do is when I click inside of a model and go Shift H, I can now just look at certain pieces of the puzzle, in this case the roof. Or I could go back and I could say, you know what, I just want to hide everything that's in my way. So the other keyboard shortcut that you noticed that I had there was hide. So I can go through here and say, okay, I just want to hide all of this. And one thing important when you're pitching a roof is that your external walls are holding up your bird's mouth here. So they're not really necessary to pitch a roof yet. And I'll get rid of this here. And I'll get rid of these external walls here. And then this way we'll get to see where our internal load-bearing walls are, so we can figure out how we're going to distribute the load of this roof. So basically the under purlin, this one is actually required. It's still an internal wall, and I'll have a mess around with that in a moment. And over here, these are external walls. I don't need them. So I'm just clicking on them and pushing hide just to hopefully see where I can distribute this load internally. Now my ceiling joists, I don't really need them either, because they're really just sort of getting in the way. And now I can get a lot better idea of where I can start to distribute this load. Okay, so these under purlins, how did I go about getting them in there? Well, essentially what I did is I drew a rectangle from the underside of my bird's mouth, because that gave me a level height. So let's see if I can, I'll just get rid of that floor there, that picture there as well. Okay, so what I want to do is figure out how I'm going to go about getting my heights and my spans and my rafters. Okay, so what I do here is I'm going to create a rectangle by using the rectangle tool, or R as a shortcut. I'm just going to go through here and just quickly put a rectangle to my furthest extremities, and that would be, say, here, and it created a face. Now the next thing I need to know is the span of my rafter. So at the moment I'm using 2x6 rafters. So if I go to Google and I just went to an American Wood Council thing here, and we've got the species of the timber, the size of the timber, we're using 2x6. It's a structural grade, you can choose that as well, and it is a rafter, and it's really good because you can now choose in here snow loads or whatever it is. And I might say this is our deflection, more of an engineer's job. Spacing 24 inches, I've already got them spaced at 24 inches. And you can put in the loads and everything, and I can calculate a horizontal span. Okay, I'm not sure how quickly this works, first time I've used it. Okay, so it's looking to me as though I can span this rafter. Where are we? Limits of use, species grade, bending strength. Right in front of me, maximum horizontal span is 10 foot 3 inches. Okay, so let's go back to our model, and it's saying the maximum horizontal span is 10 foot 3 inches. So I could now go in here and I could put an offset line, or I could offset this face F and write in 10 foot 3 inches. Enter. And it's given me a 10 foot 3 inches offset from the outside of those walls. I can now push and pull that up until I hit the underside of a rafter. And in this case, I could now have my under purlins at this height. Okay, so I really want it to be up in line with here. Then we can get inside of here, and we can push and pull this up until we hit the underside of our rafter. You can see that happening over there, and therefore I would know that that would be where I would want it to go. And I'm going to bring this back out here so that all my under purlins line up. And now I can just simply go around and trace here the outside of this here, and that'll make it very easy for me. So now what I would do is I'd go to my roof tool, go into here, and I would choose under purlins, alternatives, under purlins, and the size of the under purlin, I'm going to go 2 by 6, and you could also do that in your span table as well, and go draw, and I could simply go into here and I can navigate around and start to put my under purlins in. And you can see that one wants to come through further. I could go right through, or I could stop it there, and you can see it's just drawn it where it is. And I might want to get to the maximum length of my timber or whatever it might be, and right into size. And I can continue to go and put my under purlins in. You can see I've already done it before, so there's probably no point in going through and doing it again, but this is a really handy way to do it. Let's go through to here. And therefore I have the maximum span of this rafter according to the underpurlin. And sometimes the underpurlin might have to span further because, I'm going to undo that. Let's see if I can explain this for you. Get rid of this face. Sometimes it's going to be a lot longer before I can get to the next wall. So I'm going to use the underpurlins I put in here. I like to over-engineer things a little bit, not getting too carried away. And basically I just like to divide the overall span by 3, which means that I've got a stronger house and a happier client, I gather. Okay, so we can also use the grid tool. There's a grid tool inside of Plusspec here where we can grab it and we can write in the spacings of the grids, and I can simply go to here and say, okay, well I just want to put a grid from here to over here somewhere. Okay, and if I go to all and I hide my roof, you can see I have a grid there. I can hide my roof. And now I have a grid and I can use that grid to draw on as well. It makes it a lot easier. I'm going to delete that. Delete. So let's get back to, let's delete this face out of here that we put in before. Or even hide it, doesn't matter. And now what I can do is I can start to figure out from these walls how I'm going to go about supporting these underpurlins. Alright. The best way to do this is to maybe work in a section. So if I said, you know what, I want to run a section from here through to here, that way I can just see inside of my roof. And now I can see my underpurlins and I can figure out how I'm going to go about strutting them down to a wall. Okay. Alright, so if I go back inside of here, you'll notice I have struts from points. So I can say, okay, well, I want to have a strut that holds up this underpurlin here, and sometimes they will go in an angle. So I might have inside of here, I've got a more load-bearing point because I have a cluster of studs, therefore it's easier for me to hold that weight. So strut from point, from here, and I might say, well, we're going to have a diagonal strut over to here, and I want another strut from, say, here up to here, and I might want another strut in the center. It depends on the size of the underpurlin, and you'd go back to that span table to figure that information out. Okay. I can also put in collar ties. So a collar tie is what holds the roof from spreading. Okay. So underpurlins will still do the same thing here. So underpurlins from points. Okay, and I'm going to go from here. And I'm going to go across to, I probably should have actually done it on, I think I'm just going to go escape. And I might say from here to here. See, it's trying to reference other things there, and I'm not sure whether I actually pushed in the right thing there. See, that's not what I wanted. Right, so I'm going to delete that one. Or I could use a joist as well. So if I said I wanted to create a face, I could go and use my grid tool, and I probably should have put in the right size for the grid. Go to all so I can see it because it's on another layer. And then I could go in and use this as formwork, I gather, to put in where I want my information to be put. grid just makes it a little bit easier to line things up. Right, obviously I need to move that up a touch. And I can move those beams around to suit themselves, and I can create an array, so if we need one every second rafter, looking for my axes, and I could write in ×2 or ×3 or whatever it is, and I can put my collar ties in there. So a lot of this, the tools are available for you, it's just a matter of making sure that they're in the right locations to suit yourself. Okay, and therefore I can get a very detailed roof. The house itself, I mentioned before we had point loads, so let's go to our structure here. And here I have a point load where I've put some struts on, and I can probably move those around a touch. And what I want to do is make sure that that point load is actually going to follow through the house, so I can follow the load path. Because if this wall is not sitting over top of a structural member, basically all I'm going to do is bend the floor. So I'm just going to go here, edit, unhide, all. Okay. And here's a good example of a load path. You can see I have a strut there that's holding up, and that strut is going over top of a cluster of studs, which I actually did manually, and I'll show you how I did that in a second. And then it goes down to a joist, and that joist is free spanning from 2 walls. So I doubled the joist up, and what I would do in this case is, I'm not sure whether this is all going to work, and I'm really just trying to get a bill of quantities here. So I might go in and put a tag in. So if I go to my BIM tool, I have a tag tool, and inside of here I can scroll through and I can put a comment in, and I can assign this comment to the engineer. So I'm going to say, well, here, you know, I might need to use a glue-lam beam. I'm going to assign this to the engineer, and the location is over the rear balcony. Terribly typed out there, and the notes are please specify beam size, and then I can then put in, it might cost me, I don't know, hypothetical, an install price of $200 to do this, and I can go submit. This comes out in the takeoff as well, so I'm just going to just get rid of this here. If I did a bill of quantities on this model now, I click this button up here, and it's taken me to my takeoff, and only the things I'm looking at on screen are there. So I've got roof framing, and I have the length of every single piece of lumber that I've put in there, and it allows me to be very accurate with what I'm doing. And obviously I have construction knowledge, therefore I can put in more information than say an architect would. So probably what we're looking at the very first place is something the architect could do quite easily, which would save the builder a lot of work, and it would allow us to get more work done or do a bill of quantities very quickly on his model. But getting back to the tag, here I have the comment tag, the time that I did it, and also to the engineer, urgent, over rear roof balcony, please specify his beam size. He can then write in, well, you know, you need to change the beam size to whatever, or he could do it himself if he is a Plusspec user. You can work inside of Sketchup as well, so not everyone's going to have Plusspec, and we understand that. So if we said, you know what, it needs to be a triple joist, instead of putting a glue lam in, we can just put another joist in. This is just done in SketchUp, and therefore we're distributing that load, and then I can see over here that I'm going to need a cluster of studs underneath there, so I can just go inside of the wall here, and I can move these studs. I might say I want 3 studs under here, ×2, and there we go. If I go back and redraw that wall, it will delete those studs, so this is something you should be doing at the end of the model, and probably locking or making notes to say that that's what I have done, or the engineer could do that as well. So I'm starting to get a structural model that I can build from and I can communicate with. So as you know, hopefully you do know, SketchUp has a great app that we can export these and send them to our phones or our iPads or our Androids, and we can start to interrogate a model via these scenes. So if I go back to all, we still have a model here, and you can see that I have a beam there that's sticking outside of the roof. The reason why that beam is sticking outside of the roof is I basically just used my joist tool to put in my ceiling joist, and you can see that I still need to change the locations of some of these beams around to suit structural areas. That's sitting over top of a head. I probably really should have gone this way. looking for my red axis, and therefore I can now follow that load path down. You can see that load path sort of, it's a solid block wall. I believe that would probably be strong enough for what it's holding. This member here is just holding the weight of the center of these ceiling joists. Okay. As I mentioned before, all of these studs were put in by default, and we can change the spacing of studs according to what's required. So if I said, well, you know what, this wall here, I might think that, you know what, it's going to be a 16 ounce, and it actually works quite well. Plusspec works from the outside in, and those rafters have lined up with those studs, and you can see here I'm not quite getting that, but I do have a double top plate, so I could go in here and say, I'm going to go to my wall tool here, and I can change the spacings of these studs on this wall. Okay, so if I went to my timbers and I went in and said, well, instead of 24 on center, I want to go 16 on center, and I go down and go submit, I can now not worry about lining up my rafters because I have a shorter span between my studs, and my wall is still parametric. I can do things very, very quickly. So basically, one thing when it comes to costs is value engineering, is figuring out those span tables, which are here. And then you can say, well, you know what, I can actually reduce the size of my rafters according to the spans, or reduce the amount of labor required to put a roof together by knowing what span a piece of timber can do. Plusspec isn't an engineering tool, however it does put in the visual information for you to be able to estimate and for you to be able to engineer from. One other thing you can see here, I haven't got any, we call these outriggers in Australia, you might call them something else, but essentially what it is, it's a piece of timber that's going through here to put in something to hold up this fly rafter, I call this, or verge rafter. And to do that is reasonably simple. I can go back into my joist tool, so I can do it in my roof here, or I can do it in my floor joist. It doesn't matter, they'll both do the same thing and quantify the same thing. So I go to here, and I'll go to here, and I'll choose the size of the outrigger that I require. Well, it's already 2x4, and my verge rafter there is a 2x6. I could change it to 2x6, but I think 2x4 would do it. So you go 2x6. I don't want to include perimeter beams. I want it to be below the face, and I don't want bearer, so bearer basically sits underneath the joist to hold it up. And my spacings for this 2x6, 96 inches, I probably just want to go 2 feet or 24 inches. Go submit. Now I can figure out where I need to hold this up from. So I'm going to say I'm going to hold it up from here to here, and I'm going to go up my roof, and now I have my outriggers in there to hold up my verge rafter. It's estimating as I do that, so if I click estimate now, I'll have those in there. Plusspec automatically puts things into groups, or how it is that we would like to build. So, you know, I've gone to all, which means that everything's on, and if I did a transparent view, you'll see that I have all the structure in behind my model there. Yet sometimes I might want to be showing a client, so I want to turn my structure off, and so I can go through and have a bit of a look through the house. Okay, everything in here is parametric, and these doors open and close. But the main thing about it is we're keeping all of our information inside of one model. I also use a Space Navigator mouse for this type of thing. It's really good. I think 3D Connection would be the brand, and it just allows you to smoothly scroll around. And when you're showing clients, it's nice to be able to do this kind of thing. You know, we can go in and have a look through our garages. It also put things in like tracks, and you can see we've got a clash there. So you know what, I might need to actually go to this wall and say, well, you know what, this drop off is too low. It's really handy to know this information. So I just go back to my wall, and obviously I'm going to need a steel beam in there as well, but let's just go to our manual overrides, and our external drop off for our joist or our concrete is at 21 inches, but I can see that's a problem. So I'm going to go into here and I'm going to say, well, you know what, I think if I put 15 inches in and submit, I now have cleared my garage beam. And these are the problems that we come about on site all the time. I'm going to go back to all here, and I might go back to my structure, and you'll see that I also have steel in there. So really the distance from that drop off should have been here to suit my steel beam that's holding up my brickwork. So I can quickly see what's going on there. You might have some shear walls that you need to put in, and they are inside a Plusspec as well, some Simpson strong tie gear. You can change the angles of the beams and sizes to come up with a bill of quantities that is more accurate. See if I can find where I've got a rafter missing. Okay, over here you can see the Plusspec hasn't equated the rafters correctly, and I'm going to need to add another rafter. I click inside of it. I now select the one rafter, and I need to move this rafter down so that the minimum is 24 on center. I could use a tape measure tool. Here I can take a guess, and now I can take a measurement between here and here. I've got 1'9", and over here I have just over 2 foot, so this rafter needs to move down further. Or I could probably be a little bit more accurate and say, okay, from here to here I want it to be 24 inches, and enter. And now I can see exactly where my rafter needs to go. I overdo things a little bit. Sometimes I'd rather have it a little bit longer so I'm not short on site, so you can see that that is there. But I understand some people are a little bit particular about that. We can go inside of here, and we don't use the scale tool. Okay, the scale tool will still give us the same size timber. We would just basically use the move tool in this instance, and I might say, well, I want to move this back up the rafter. Okay. It's estimated that as well as I've done it. Okay, I hope that it helps explain some more of the complexities behind Plusspec and some of the power that you have to be able to do this kind of work. I've done this, guys, without any edits or anything like that. This is just a straight video. Ceiling joists might be something you want to know about as well, so I'm going to go into here, and I'm going to say, I'm going to hide this here. Hide. Use my rectangle tool as formwork. Go over to here, and I'm going to put my ceiling joists in. I would want them to go this way, so I'll go back to here. Here. Choose the size of the ceiling joist I want to do. And I'm going to actually go not below face, I'm going to go above face, because I want to have what I call a stringer, which is basically this piece of timber up here that holds the center of the ceiling joist up. You can also have things called strutting beams, which is a beam you strut off. You never strut off a ceiling. And I say I want this 96. Oops, number lock is on. 96. Oops. 96. Why isn't my keyboard working? 96. There we go. And I'm going to use 2x6. I'm going to use 2x4. So I'm going to actually enable these. I'm going to use these as my ceiling joists and go submit. Which way do I want them to run? Well, my stringers are going to go this way. Turn my structure on, and now I have, and if I unhide last, edit, unhide last, you can see that I now have a couple of beams that I don't need. So I don't need a ceiling joist there on the outside, so I'm going to delete it. These stringers are sticking out past the roof there, so I can go and pull them in if I choose, or even cut them if I said, oh, you know what, I want to cut this from here to here. It will still quantify this rafter, provided you're not using the scale tool. Okay. And I might actually also want to have little returns here for trimming out. This one here I don't need. Oops, so I've done too many, delete. And this one over here I don't need. And I might want to just move these around. You would also use your span tables to work with these as well. I could just say, you know what, I've already trimmed this one here, so I'll move this one in its place. Move, I'm going to go from somewhere where I know I'm going to move from. Okay. And I would also need to strut this roof as well and put under purlins in there as well. I could also use trusses. So if I said, you know what, let's delete this roof here and delete these ceiling joists. One thing good about a truss is that a truss roof will self-support, and it can be put together a lot faster. So I'd go back to my roof tool, choose the pitch of the roof, 1 and 2, Can't remember what the ratio was on that other roof. My overhangs, whether I want them to be a plumb cut on the end of my rafters. Do I want a Dutch gable? No. Okay, so I just want this to be a hip roof. Okay, upstand is the distance from the bottom of the truss up. I assume that everyone knows what that is. I don't want to include valley trusses in this particular area, and I'm going to go submit. This is also a complex calculation. Alright, I need to be 8 inches back. Sometimes you get a black screen, sometimes you get a little bit of things going on and working there. There we go. And now I have my trusses. It also showed me that I have a load bearing truss here, which is a girder truss, because this truss is holding these trusses as well as it's holding its weight here as a rafter, and it allows me to see, well, I might need to upgrade the size of this beam or put a steel beam in to make sure that the point load on this truss is not there. I can also change the distance of this as well. Okay. This is a pitched roof. In Texas, labor is cheap, therefore it's cheaper to do a pitched roof or a stick timber roof. Alright guys, hope it helps you out. If you've got any questions, by all means put them in there. We might get into beams later, so you can see I've got to put some beams in there. Beams are very easy to do. I'll do it very quickly. You can still use your joist tool to create beams. Choose the size of the beam that you want to do, and I just want to make sure it's below my face here. I don't want a ceiling, and I don't want to include floor because it's just a beam. Go submit, and essentially I can figure out where I want my beam to run from, and I'll do this very quickly. I can extend these later if I choose. I'm going to beam from here to here, say. Okay. You put a double beam in there, I can go through and I can delete what I don't want. If I want single beam, just delete that out as well. Okay, if I change the spacings there, I wrote no end beam, and then I can go and say, well, I want this to line up with my post. I can extend my post up. I can see it needs to be extended up there. And I can do the same over here. Center of my ridge, and now I can see that I'm going to need a post there as well. I can then move my posts over, or I can add another post. Bit of a strange sort of looking post, this one here, or however we're going to do it. I can add in eave linings, I can add in drop-offs, different changes and so on to suit my model. Alright guys, look, I hope that helps you out. Give us a like if you enjoyed the presentation. Cheers.